I'm lucky I am not the last one. So you would have blamed me for being late to finish it off. So there is someone after me. And good afternoon again. Thanks, International Therm Process. So in this session, I would like to give a brief of burner technology, our development and research center of Danieli Centro Combustions, how we are trying to make a greener environment with low NOx and SOx with our burner in our research center in collaboration with the University of Genoa. So Danieli, people know about our mills. Obviously, we are pretty well known, and also for the reheating furnace as well. So it is it is not only steel industry, we are also into aluminum heat treatment after taking over a company, around 100 years old company called Olivotto Ferre in Italy. So I am looking after heat treatment segment, which is the Olivotto Ferre products. But today I'll showcase in general the burner products of Danieli. So our group turnover, it is an old figure, it's more than 2.8 million. Now it is, I think, 3.2 or 3.3 million euro per year. We employ around 15,000 people around the globe. Just a brief introduction, our worldwide workshops. There are one in the Butio in the left corner, which is our main plant. Then we have Far East in Thailand near Rayong. Then we have a workshop in China, in Changshu, and Russia, and last is the Sri City in, not Chennai, it is in AP, but close to Chennai. Then we have our Danieli Centro Combustion office. These are the Danieli, global Danieli factories, not Centro Combustion itself. But this one, our Danieli Centro Combustion division, which is looking after the furnace. So these are the main offices. We have our head office in Genoa, Olivotto Ferre office is in Turin, our corporate office, Centro Combustion Pune office. Then we have a research center in Savona near Genoa, and China, Centro Combustion China, which is recently being opened. So what is our product portfolio? We have under the reheating technology, walking beam, walking hearth, pusher furnaces, rotary hearth, roller hearth, furnace for thin slab casting, heat transfer tables for, again, thin slab caster machines, Steckel furnaces. And under heat treatment technology, we have annealing furnaces for galvanizing lines, ovens for color coating line, roller hearth furnaces, quenching tempering system for flats and tubes and bars, bell annealing furnace in hydrogen or nitrogen atmosphere, and pit furnaces for ingots or bloom heating. In non-ferrous, we have continuous slab heating system for mill or also for homogenizing. We have a coil annealing furnace, which are, some of them are as per AMS 2770, 2750 class D norms. Then we have billet homogenizing, slab homogenizing, and for solution annealing furnace for forged components, and aging lines for automotive, like wheels and pistons like that. Now I go next to our main topic, that is the burners. So thanks to our research center, our guys in the research unit, the University of Savona, Danieli over the period of time has been able to produce some of the best burners, I would not say some of the best burners for reheating technology, for heat treatment furnace with very low NOx, and also low SOx, and then using very low calorific value gases like BFG mixed with LPG or mixed with other gases, flameless burners, oxy-fuel burners, and so on and so forth. So what is our aim? Our aim is to reduce the NOx, particularly NOx values, which is an important factor for environment control. And we are trying to comply with the severe most regulations of Europe. I think you'll be very happy with that. So the movie is not working. It could show the flameless mode and the flame mode and how the NOx values changes with that. So we are trying to use optimum fuel condition less than 1.15, which my predecessor has aimed at, trying to do it at 10% excess air or even low if possible, so that we have the least consumption of gas or fuel. Then the flame patterns, obviously it helps in giving a very better thermal efficiency inside the furnace, so that you can have a best temperature uniformity and also the best consumption of gas. So I'll go through with some of the burners for reheating furnaces. This is a diffusive flame for lateral and frontal walls, and also for flat flame roof burners. First I'll go with the wall burners. This is a burner with high calorific value gas. This is a flame condition, this is a flameless condition. Obviously the NOx values, I will come to that, how the NOx values differ with these two conditions in the next slides. Then again, we have a burner for reheating furnace, which we have used in Bhushan steel plant in Jharsuguda, using BFG mainly and mixing with liquid LPG to achieve a calorific value of around 1200 to 1400 depending on the output temperature. And this is the burner flame mode. You can see this is not a flameless burner, it's a flame burner. This is installed in Bhushan, and we are again installing another furnace with a similar technology in Bhushan as well. This is a flameless burner, low NOx, using coke oven gas. This is the flame condition. You can see the flame here. Yep. This is a flameless combustion. Hardly you can see the flame, but it is burning. See the NOx values, 550 to 100. It's absolutely fantastic figure, I believe, if you agree with me. Thank you. So next we go to, again, a burner for reheating furnace. This is ultra low NOx. Sorry. This we have successfully installed in two places, Monesman, US and Valurek. This is again a flame condition. This is flameless condition. This is the NOx value with flame condition. This is the NOx value with flameless condition. And this is a patented burner of Danieli Centro Combustion. This is again, this is again normal wall-mounted burner with flame condition and flameless condition, and you can see the values changes with the NOx values changes with the flame condition and flameless condition. So this is again with a coke oven gas. This is a roof burner. I'm sorry, the movie is not working. But again, I can show you the values for the flame condition. The left-hand side is the flame condition, right-hand side is the flameless condition. The value of NOx, you can see, is extremely good. Then we have also burners for heat treatment furnace, which are long flame burner to achieve a very good temperature uniformity throughout the furnace width. These are high-speed flame burners with preheated or cold air, both. This can be self-recuperative as well to have a very good thermal efficiency. We can heat up with a 1250 degree, 1050 degree furnace temperature. The preheat air can be as high as 800 to 900 degrees centigrade. This is again a patented burner of Danieli. So it's a high-speed recuperative, self-recuperative burner, wherein we can preheat the air to the burner around 800 degrees centigrade if the furnace temperature is up 1000. This is also a silicon carbide tube burner, mainly for galvanizing lines. We have used in Arvedi with a 2P radiant tube. I think my predecessor from Drever already shown 2P burner system, so I'll not go into that. So this is a typical burner figure which takes care of self-recuperation. This is a burner for free flame zone in the horizontal furnace. It's a normal burner, not a flameless one, but it can work at a less than stoichiometric air value to produce a reducing atmosphere inside the furnace. Sorry. This is my predecessor has already shown, so I'll not go into that. So now we come to our research and development facility in Savona. Here we are trying to develop new burners with various types of combustible material, low calorific value. Even we simulate BFG with a mix of nitrogen, carbon dioxide with LPG or natural gas bottleneck source, so that we can actually simulate a BFG gas and fire it inside our test furnace and see the result, how the burners are behaving. So there is a theoretical calculation in working in tandem with the University of Genoa, sorry. There are CFD simulations, and then we are doing kinematic chemical analysis of the combustion. And then we are customizing our burners. The burners are not off the shelves. Each project is taken as a new project. The burners are tested according to the preheat air temperature, the gas, the pressure of the gas available, and the specific operating parameters, the output temperature, the furnace temperature, etc. So the customized burners are obviously extremely fuel efficient, and they are specifically manufactured for a particular condition, so they are obviously much more efficient than normal off-the-shelf burners. So these are some of the results of our CFD calculation and theoretical calculation in the research center. You can see the flame patterns are taken care by CFD calculation. These are some of the pictures. This is a 3D model of our research center, so where we can arrange burners from 30 to 3000 kilowatt, and utilizing, as I told you earlier, various fuels and oxidizing agents. And fuels can be BFG, which is 760 kilocalorie per meter cube, to LPG, which is around 28,000 kilocalorie per meter cube. There are two test furnaces which simulate a furnace actual condition. By way of load, we are recirculating water inside the furnace, which simulate actual load of the furnace, and then we test fire our burners inside the furnace to see the result. You see these these lines are the water tubes, which is simulating a load inside the furnace, actual load. Maybe suppose we are making a burner for a 200 TPH furnace. So by way of water flow, we are simulating the actual load condition and then test firing a burner with that particular gas. So if it is, say, low calorific value mixed gas of, say, 2000 or 1800 kilocalorie, we are simulating that, the same composition of combustion gas, and firing inside the furnace. This is the control center. This is the water tubes which make a dummy load inside the furnace. So as you see, the thermal absorption of the feedstock introduced inside the furnace, simulating actual load condition. We have set some targets for the future, keeping in step with the requirement of environment, with the economics and demands and global demands. So these are emission reduction, reduction in gas consumption. So this is our future targets. Some of them we have achieved, some of them we are trying to achieve. We have made some patents of new burners, but not yet come into production. We are still test firing them and market them very soon. So this is one of our target, regenerative burner, wherein you can preheat the air temperature just 100 degrees less than the furnace temperature. If your furnace is operating at 1200 degrees centigrade, the preheat temperature can be as high as 1050 or close to 1050 or like that. So you have extremely efficient burners, but our regenerative burners are slightly different from the conventional regenerative burner, which are in the conventional regenerative burner, they work in pair. So if you need a particular area 3000 kilowatt of heat load, so you need to use each burner of 6000. So because in a conventional regenerative burner, one burner is in fire mode and the other is in the suction mode to preheat the media case. But we have developed a slightly different regenerative burner. So it's a single burner which throws in the gas and sucks in like a self-recuperative burner. So the burner is as per the required thermal capacity. It is not double. It is, if you need a 3000 kilowatt burner, it will be 3000 kilowatt burner only, not 6000 in pair. So that one is firing and another is sucking. So this is also again a patented burner. We have a patent on this process, but it has not yet been launched in the market. We are still fine-tuning the product. We have made some prototypes and they are being test-fired in the test furnace you have seen already. Maybe, hopefully by next year, it will be launched officially as a DCC product. And also, we are also making burners oxy-fuel, which is again reduces carbon footprint, reduces NOx, reduces reduces your fuel consumption drastically. So this is also again burner in research condition. That will also maybe around in 1 year time, it will be launched in the market, DCC oxy-fuel burner. So this is already one burner we have already done in CR group, which is oxygen enriched, not exactly oxy-fuel. But oxy-fuel is already is under process of research in our research center and may soon be launched. Soon means it may take around 6 months to 12 months. So that's all. It's a short presentation. Thank you. Thanks for your